In part A, we determine the number of ways the group can sit in the four chairs. So we have Bob and six friends. So therefore, there are actually seven persons who goes to the restaurant, and there are only four chairs available. So let's put the chairs as like this dashed line. This one represents the first chair, this one the second, this one the third, and this one the fourth. Now, coming from the left, that is the first chair. So, in this chair, there are about seven persons. So, possibly there are seven different ways that the persons can sit. And once one person has sit in the first chair, then we have three chairs remaining. And in the second chair, out of seven minus one equals six persons are left now. So, there are six possible ways that the persons can sit in this chair, second chair. And similarly, in the third chair, we now have two persons already seated in the first two chairs. So therefore, five persons can sit in the third chair, and in the fourth chair, four persons can sit. So now we have to multiply these numbers. So this much of ways the persons can sit in the four chairs. That is 7 times, 6 times, 5 times 4. 5 times 4, I will multiply like this. 7 times 6 is 42, and 5 times 4 is 20. And so this equals, we can multiply like 42 times, write 2 as 2 times 20, I'm sorry, 2 times 10. And so now we can easily multiply these two. 42 times 2 is 84 times 10, and this equals 840. So this is the 840 ways. So the group can sit in about 840 ways in those four chairs. Alternatively, we can do the same problem using the permutation formula. That is, I'm going to use this. Let's put this one as alternate method. Here we use the permutation formula. That is, if there are n objects taken r at a time, it is NPR, and this one is according to the formula. This one is n factorial divided by n minus r factorial. And here there are seven objects taken four at a time. We consider the persons as objects, and these seven persons, out of these seven persons, only four persons can be seated at any time, which means n equals 7 here, and we are taking only four objects at a time. That is, only four persons can be seated at any time. So we can utilize this formula. Using this, we write this as 7p4, and this equals, according to the formula, it is 7 factorial divided by 7 minus 4 factorial, and this gives, I'll write this below, this gives 7 factorial divided by 7 minus 4 is 3 factorial. And so this can be written as 7 factorial is basically 7 times, 6 times, 5 times, 4 times, and then 3 factorial. And this divided by 3 factorial. So we can cancel out this 3 factorial and 3 factorial. And finally, we are left out with this product of these numbers, which we obtained in a similar way when doing the first method. So this one is 42 times 20, and this is once again 840 ways. So we obtain the same results when we did by the formula method as well. This is 840 ways, the same as we did in the first method. So there are 840 ways that the group can sit in four chairs. In part B, we determine the number of ways that the group can sit if Bob has to sit in the first chair. So I'm going to put Bob over here. So this position is fixed, which means this is only one way only one way is available. That is, only Bob can sit over here. And for the next three remaining chairs, that is in the second chair, since Bob is already going to be seated in the first chair, then there are six friends. So therefore, this has six different ways. Six persons can sit in the second chair anytime. And then the next chair, since two persons are used, this will be five. And the fourth chair, this will be four ways. And this means we multiply these numbers. Notice that the first number is 1. So we multiply like this. It is 1 times, 6 times, 5 times, 4. And so this equals 6 times 5 is 30 times 4. And this equals 30 times 4 is 120. So there are about 120 ways available if Bob has to sit in the first chair.